Okay, so now we're going to be talking about our empirical rule. Pretty cool now. We're going to be able to talk about empirical rule. Let me share the screen there. That's what I want. Okay. Having problems sharing. Okay, so here I want to talk about what we call the empirical rule. Now, the empirical rule separates our probabilities. It gives us probabilities. One thing I'm going to be using, I'm going to be using the Greek letter mu, which looks like a U with a tail at the beginning. It's a Greek letter mu, which we're going to use for average. Now we use that usually for the average of the population. Another case that we use the word average, I'm going to use it later on, going to be an X with a bar on top. That's usually the average of a sample, okay? But those two symbols are going to be representing average. Now, this Greek letter called sigma, it looks like this. This is going to be our standard deviation. That's why last homework, I wanted you guys to practice how to find an average, how to find a standard deviation, how to find a variance, because we're going to be using those a lot. Now, the empirical rule, what it states is if our formula, our data, let's say I have some data and I plug it in. Let's say I do a number line up here. I plug it in, and then let's say here I have my average. There's going to be a bunch of numbers here around my average. Gonna be a bunch of numbers, and then it's gonna be some numbers to the sides that are not gonna be that many, but it's gonna look like that. And then we come in and say, oh, it looks like a bell shape. Give or take, it looks like a bell shape, and that's what we're gonna call a normal distribution. Okay, so it looks like a bell shape. Now, interesting part, want you guys to focus here in the center. It's our mu, it's our average. Now, if you go from our average plus one variance, and then you go our average minus one, one standard deviation, not variance. So our average plus one standard deviation, our average minus one standard deviation, it will give us this area. Now, empirical rule says about 68% of our data is going to be within that range. It's going to be pretty close to our mean. You can go as far left as average minus one standard deviation, and you can go far right as average plus one standard deviation. 68% of our data is going to be there. Now, that's why you guys see 34% and 34%. Each of those sections was cut into half. Now, another cool thing, let me erase this. Another cool thing the empirical rule tells us is from our mean, if I go as far right as mean plus two standard deviation, and then I go far left as mean minus two standard deviation. So I go from here to here. Want us to look up here. Empirical rule says about 95% of our data is going to be in that section. 95%. And look, it broke it down as 13.5, 34, 34, and 13.5. If you guys add those four numbers, I'm not going to ask you to do it. If you add those four numbers, 13.5 plus 34 plus 34 plus 13.5, should give you 95%. So it says 95% of our data is going to be in this area, in this region. Okay. But then another thing we have is, what if I go from our mean as far right as 3 standard deviations, and then I go from our mean as far left as 3 standard deviations? when I look up, empirical rule says in this area is going to be about 99.7% of our data. 99.7% of our information of our data is going to be in there. And he broke it down. You guys can see he broke it down into regions: 2.35, 13.5, 34, 34, 13.5, and 2.35. If you add those numbers, it should add up to 99.7. Now, anything, 99.7 is not 100%, right? There's still more. There's still more than that. And that's what we have the remaining outside of it. Outside of it, it says from here, you guys can see where I'm looking at. Our mean plus 3 standard deviation from there to the right is about 0.15% of our data. And then here, from mean minus 3 standard deviation to the left, it's about 0.15% of our data. Now, 0.15 is not even close to 1%. So, matter of fact, when I add those two, it should give me about 0.3%, right? 0.3. So it's not even that much. That's where we have our numbers that we used to call outscales. Remember, they were off. So we're going to be using our empirical rule a lot. In order for us to be able to use it, we're going to have to find our average, our mean, and then we're going to have to find our standard deviation. So let's take a look at here. It says the following is a sample of sanitation scores for 20 cruise ships. And it gives me a list of 20 numbers. And then here's asking me calculate the following intervals, round to 2 decimal places as needed. Okay, so here, first of all, one thing I'm going to be doing is let me find our average and our standard deviation. Those things I need. Okay, so let me use Excel. I'm going to use the 20 numbers that they gave us on the list. So 90, 85, 82, 88, 86, 92, 89, 91, 90, 96, 88, 84. Again, I'm using the list that was given to us: 99, 92, 90, 87, 94, 85, 88, and 91. Okay, 20 numbers. Okay, let me find my average. Close parentheses, we're done. So the average is 89.35. Good. Now I know for each of this, let me see the deviations. I want to go equals this number minus the average. But remember, I want to lock it in. And then I drag this little dot. I'm going to check a random point. Yeah, A14 minus A23. Good, it worked. And then here I'm going to go B1 times B1. I double checked. Yep, it worked. It worked on all of them. Good. So I need to do the sum, variance, and standard deviation. So I'm just going to add them all. My variance is going to be this number divided by 19. There's 20 numbers, right? But it's a sample. So there's 20 numbers, so I divide by one less. Okay, so I divide this by 19. My variance is 16.97632. Standard deviation is going to be SQRT, open parentheses, of my variance. So my standard deviation is going to be 4. I'm going to call it 0.12. I want to use 2 decimal numbers. 4.12. Okay. So my average is 89.35 and my standard deviation is 4.12. Okay, we got that? Okay, so now let's see. Let me go here. Let me write something really quick. Our average and our standard deviation. So standard deviation was 4.12. I remember that. And I remember my mean was 89.35. Now here we're going to calculate the following intervals, round to 2 decimal places as needed. Okay, for our empirical rule here, we're going to be using this in a minute. I'm just going to go see how here to have X bar. Remember how I said sometimes we're going to use the letter mu for average, and sometimes we're going to use an X bar. Okay, so X bar minus, I'm going to go minus because I'm going to go to the low, 89.35 minus 4.12. So my first number, I have to go the average. I have plus or minus. I'm going to do minus first, the standard deviation. 89.35 minus 4.12. I'm going to call that 85.23. And that's going to be my interval here. My lowest number is going to be 85.23, comma. And my second number, I'm going to go 89.35 plus. Now I'm going to do the plus 4.12. 89.35 plus 4.12 is going to give me 93.47. So when I'm asking you guys to write it as an interval, this is what I mean. Here, notice at the beginning, I wrote down average plus or minus 1 standard deviation. So just went average minus and then average plus. We're going to call this interval notation. So we do the smallest number first. So I had to do minus. Okay, now here for my next example, I have average plus or minus 3 standard deviation. So it might be like, okay, Mr. Leonzo, what am I going to write on my calculator? Okay, I'm just going to type in 85.35 minus 3 times 4.12. I'm going to type this in. Let me put a little square, a little rectangle, so you know what I'm typing in on my calculator. I went average minus 3 times the standard deviation. I type it all together. The calculator knows that it has to multiply before it subtracts. My case, my calculator gives me 76.99. That's my first number. For the second number, instead of minus, I'm going to change this to a plus. So 89.35 plus 3 times 4.12. And my calculator gives me 101.71. Cool. Nice. Not that bad. Okay. Now, I'm going to use this table for the following questions, okay? Our mean, our average here in the center is 89.35, right? Our mean minus 1 standard deviation is going to give me 85.23. Our mean, so 89.35 minus 2 times 4.12, so 2 standard deviations. I get 81.11. And then mean minus 3 standard deviation, I get 76.99. Now on the right, our mean plus 1 standard deviation, I get 93.47. Our mean plus 2 standard deviation, according to my calculator, I get 97.59. And our mean, plus 3 standard deviations, I get 101.71. Okay, I need this information for the following questions. It says find a percentage that is estimated to land in the following interval. Okay, the following interval from 81.11 to 101.71. So 81.11 is right here. 101.71 is right here. So how much data are we going to have in between those? All I'm going to do in reality, I'm going to add these numbers. 13.5 plus 34 plus 34 plus 13.5 plus 2.35. I add those percentages and it gives me 97.35. So 97.35%. Here it says find a percentage. So I'm just going to write 97. Oops. I should use a pen. 97.35. Right? It asked me for the percentage. So I had to do it in percent. 97.35%. Just write the number. Now the next one, it says find the percentage that is estimated to land in the following interval from 89.35 to 97.59. Okay, let me erase this. So it said from 89.35, so that's this right here, to 97.59, which is this right here. So it's asking how much it will be in this area. To be honest, I'm just going to add these two percentages, 34 plus 13.5. That's going to give me 47.5%. So now here I'm going to go 47.5. Don't have to write the percent symbol because it's asking in percentage. So it means that I'm dealing with percent. Now, one thing really quick, because sometimes I might ask you, find a percent. Sometimes I might ask you, find a probability. Okay. Now, this is the percent, what we have, right? 97.35%, 47.5%. You notice they're big numbers, right? It's a number between 0 and 100 with decimals included. Now, probability is the percentage written as a decimal because percent means for every 100. What I'm going to do, I'm going to write this number as a decimal over 100. So I'm going to go 97.35 divided by 100. It will give me 0.9735. The second number, 47.5 divided by 100, is going to give me 0.475. Remember how back in foundations, or some of you guys middle school or elementary, sometimes some of you guys learn how to go from percent to decimals, like percent to fractions, things like that. This is percent, 97.35. I divided by 100, so it gives me this decimal. 47.5, I divided by 100 gives me this decimal. I know some of you guys were told move the decimal 2 places to the left. Some of you might remember that. Now, if I ask you for percentage, percent, I expect this numbered in red. If I ask you for the probability, I expect this numbered in blue. Okay, let me say that again. If I ask for the percent, I expect these big numbers. If I ask for probability, I expect these little numbers. Probability is a number between 0 and 1. So 97.35, not quite. So the percent divided by 100 gives me my probability. The same thing, if I was to give you probability times 100, gives you the percent. We're going to be dealing, in this unit, we're going to be dealing with percentage and we're going to be dealing with probability. So, okay. Just wanted to leave that. So, might be asking, okay, Mr. Leonzo, so for these, why do I use the red answers or the blue answers? I'm asking for the percentage. So then use the red numbers, 97.35, 47.5. I just wanted to emphasize that percent can be converted to probability. Okay, so now here, let's take a look at this last example for today. These last two examples. Natural stone, such as sandstone, is a popular building construction material. An experiment was carried out in order to better understand the decay properties of sandstone when it's exposed to the weather. Blocks of sandstones were cut into 300 equal-sized slices, and the slices were randomly divided into 3 groups of 100 slices each. Slices in the group A were not exposed to any type of weathering. Slices in group B were repeatedly sprayed with a 10% salt solution under tempered condition, and slices in group C were soaked in a 10% salt solution and then dried. Okay, so far, what have I read? I read that there's some sandstone, some blocks of them. I had 300 of them, so I broke it into 3 different groups. I treated each group, right? There's 3 groups. I treated each group differently just to see whether the weather changes the sandstone or not. Now, all sandstone slices were then tested for permeability, measured in millidarcies, which is a measurement. And now this permeability values measure pressure decay as a function of time, measures of central tendency variation of a permeability measurements for each sandstones group are displayed below. Okay, so group A, there's 100 of them. The mean is 73.88, standard deviation 13.03, the minimum and the maximum values. Now here, approximately 99.7% of the permeability measurements for group A, so that means I'm just focusing on group A, will fall between, and there's between 2 numbers, 99.7%. Okay, I remembered, according to my empirical rule, 99.7% is going to go as far down as the average, or mean, minus 3 times the standard deviation. And then it's going to go as far up as the average plus 3 times the standard deviation. So you guys might be wondering, okay, so how do I do this? Okay, the first number, I'm going to do 73.88, because that's the mean, minus 3 times 13.03. All I need really is the mean and the standard deviation. That's all I need, because it's 99.7%. I know my empirical rule says 3 standard deviations. So I'm going to type this on my calculator. 73.88 minus 3 times 13.03. Right? I know my calculator knows that I multiply before I subtract. So it gives me 34.79. Now for my other number, I'm going to use the same formula. The only difference, instead of minus, I go plus. So 73.88 plus 3 times the standard deviation. According to my calculator, I get 112.97. Now I'm going to remind you, round to 2 decimal places as needed. Good, I got 2 decimal places. Use ascending order. So what that means is put the small number first and then the second number. Okay, that's not bad. For the next question, so let me erase this. Approximately 68% of the permeability measurements for group C. So I'm looking at group C this time. I remembered all I really cared is the mean and the standard deviation. Okay, 68%. According to my empirical rule, I'm going to go as far back. My formula is going to be the mu, the average, either plus or minus 1 standard deviation. Some of you might still be wondering, how do you know when it's 3 standard deviation or when it's just 1 standard deviation? Okay, let's take a look. Remember how I used to have this? Let me erase this stuff right here. The first question was asking for 99.7%. Do you see that right here? 99.7. So how far back did it go? The mean minus 3 standard deviation. How far right does it go? The mean plus 3 standard deviation. That's why I did that first question like that. Now, the second question is asking 68%. You see 68% right here? How far back does it go? The mean minus 1 standard deviation. How far up does it go? The mean plus 1 standard deviation. Okay, now that we understand that, let me come back to our question. So plus or minus 1 standard deviation. So, okay. So in our terms here, the mean is 123.33, right? So I'm going to say 123.33 plus or minus 1 standard deviation. So it's 20.62. For my first number, I'm going to go 123.33 minus 20.62. So it's going to give me 102.71. My second number, I'm going to go 123.33 plus 20.62, and it's going to give me 143.95. For today's lesson, I really want you guys to practice the empirical rule. Understand how far back do you have to go? How far right do you have to go? Understand the probability, the percentages here. I want you to be able to add the percentages. We're going to be using this rule a lot. We're going to be moving into later on something that we call C-scores, and we're going to be using these probabilities a lot. The empirical rule is very, very important. So this is what I want you guys to practice on